Hello guys, welcome once more to another video on our YouTube channel. So in this video I just found an equation here, and the equation says that we should find the integral from 0 to ln 2 of 1 divided by 5 cosh x plus 3 sin x with respect to x. Alright, so we are going to use the definition of the cosine functions and the sin function. So basically, sin of x is equal to half into e raised to the power x minus e raised to the power negative x, and then the cosine of x is equal to half into e raised to the power x plus e raised to the power negative x. Okay, it therefore means that 5 times the cosine of x plus 3 times the sin of x will be equal to, now if I take 5, I'm going to have 5 on 2 into e to the x plus e to the negative x, then plus we have 3 divided by 2 into e to the x minus e to the negative x. Okay, so if we bring like terms together, 5 on 2 e to the x plus 3 on 2 e to the x is 8 on 2, which is 4 e to the x, and then 5 on 2 e to the negative x minus 3 on 2 e to the negative x is 2 on 2, which is just plus e raised to the power negative x. Okay, so from here now, let us see how we can integrate this. So it therefore means that my integral I becomes the integral from 0 to the ln of 2 of 1 divided by, if I can remember well, it is 4 e to the x plus e to the negative x with respect to x. Okay, so if I multiply the numerator and the denominator by e to the x, I'm going to have e to the x dx in the numerator. When I multiply 4 e to the x with e to the x, I basically have 4 times e raised to the power x, all that squared. When you multiply, let's put a ln 2 there. When you multiply e to the negative x with e to the x, you get 1. Okay, because it's e to the negative x plus x, which is e to the power 0. Now from here you realize that if you differentiate the denominator, you kind of have the numerator. So my substitution is going to be u equal to I can say u equal to 4 times e to the x all squared. Yes, 4 times e to the x, or in fact no, let's not use that substitution because there is a square there. So let me see, we can let here we cannot use a we cannot use a u substitution. We are going to use a trigonometry substitution. Okay, so I'm going to rewrite this as, let me use the dark coloration, I equal to the integral from 0 to the ln of 2 times e to the x dx divided by, now I'm going to write 4e to the x all squared as 2e to the x all that squared, then now plus 1, so that I can now use a perfect substitution. If I let 2e to the x to be equal to the tangent of theta, right, and then I differentiate both sides, I have 2e to the x dx, where I differentiate the left hand side, equal to sec squared theta d theta. Okay, from here now I'm going to get e to the x dx because it is my numerator. Okay, so this is going to give me half times sec squared theta d theta. Now if we change bounds, in fact we are not going to change bounds. Okay, we are not going to change bounds, so let's go to the next slide. So we are going to have that I equal to, let's just get the indefinite integral. So the integral, the numerator e to the x dx, we had it as half times sec squared theta d theta divided by, now the denominator was 2e to the x all squared plus 1, but 2e to the x was tan theta. When we square it, we have tan squared theta plus 1, but tan squared theta plus 1 is the same as x squared theta, so they cancel off, and then we just get half times the integral of the theta, which is basically theta divided by 2, okay, plus a constant. But now we know that 2e to the x was equal to the tangent of theta. It means that theta is tan inverse of 2e raised to the power x. So it therefore means that my integral I will just be equal to half times theta is tan inverse of 2e to the power x. Now we need to fit the bounds from 0 to the line of 2. These bounds were for x. That's why I could not put 0 to line 2 here, because if I put 0 to line 2 there, then I'm wrong, because 0 to line 2 is not for theta, and I never wanted to change the bounds. So now let us see what we have.